Okay, folks, section 3.2, going to do a example of using the product rule. All right, and so what I've got here, this is a homework from a question from the homework. I think it was actually a pre-lecture to the product rule. However, they end up giving you the product rule in the lecture in this problem. So a good little problem. And this web assignment actually talks you through two different ways of getting this derivative, and I'm going to emphasize that also. So first off, I want to use the product rule because that's what this is an example of. So I want to do it that way to practice how that works. Then I want to show how, in this case, we can actually avoid the product rule and do something else and still get the answer. So we'll talk about that. Okay. First of all, let me mention some sort of little technicality. Okay. What I did up top here is I reprinted the product rule in the order that I presented the terms from the previous video. So if you didn't watch that, you might think these terms look a little bit mixed up compared to the book. But essentially, I've got two functions being multiplied, which I'm calling the different pieces f and g, and I want to take their derivative. Okay, so I'm using the d notation on this left-hand side, but that means I want to take the derivative of this function that lives under here, which is really a product of two functions. And what I'm told is the derivative of that function is here. I'm going to add up these two products. And then this is basically one function times the other derivative, and then the other function times the first derivative, right? So watch my other video if you didn't already, and if the order is throwing you for a loop. But anyway, that works for our product rule, okay? One sort of technicality is I'm going to change this. So in the previous video, I called the product function p of x, right? Here, and which is pretty common, is they're just giving me this function, and they're calling it f. Okay, that can be a little bit tricky though, because to use this rule and the notation that's written, I want to call this thing f, right? In other words, I want to say f of x is 1 plus 2x squared. Right? I want to be able to say that so I know what f and f prime is in this formula over here. So I want to call that piece f, and I want to call this thing g. In other words, I want to claim g of x is x minus x squared. X minus x squared. Okay. So there's no problem with calling that guy g. How can I call this f, though, if the parent function, or this combination function, is already called f? Right? So it doesn't make sense to call both a piece within the other function f. So the way I get around that is just change the name of the original function. Right? No big deal. I can call that p of x. If you're good with using the product rule, you can actually use it without even necessarily invoking these titles f and g, right? Just kind of figure out what the pieces are, plug them in where they belong, and then you don't have to worry about what you're calling f. But just a little technicality there is I don't want to reuse a letter. I don't want to rename something, a letter for a function if I already got something called that. Okay, so I look at this thing, I identify I've got a product here. 1 plus 2x is one term, times x minus x squared is another term. So I'm going to use the product rule. So in order to use that, I want to call this first piece f and the second piece g. Okay, and then I put each function over here, and now let's find each derivative. So I'm kind of finding the pieces before I need them. So if we're calling f 1 plus 2x squared, and now I'm going to be using the shortcut rules that we covered in the previous sections. So the derivative of a 1 is a 0, so I don't really have to show that. Then I'm going to add that 0 to the derivative of this term. And combining our constant multiple with our power rules, I'm going to take this 2, bring it down, and ultimately multiply it by that 2, which means I'm going to get a 4, and then x, and then I'm going to decrease the exponent from a 2 into a 1. So I could write 4x to the first power with a little 1 there, or just leave it like that as 4x. So let me just leave it like that. So that's our f prime, and now let's find g prime. Okay? Again, term by term. So I've got a minus sign here. So remember the subtraction rule, or the difference rule, says just take the derivative of each term, and then just subtract those. So the derivative of this x is a 1. We've covered that together. The derivative of x squared is a 2x, right? And then I'm subtracting the original terms, so subtract those two derivative terms, and there we go. Okay, so I've got these 4 little pieces right here. All right. Professor Ziegler, he's the math department chair right now. When I had him as a professor, he used to call something like this the mise en place. All right, so if you guys are into cooking or watching cooking shows, mise en place is a cooking term. It's French. It just means everything in its place. And so kind of getting all your information ready to go is helpful, right? Because now I've just got my pieces now. Another friend of mine now says plug and chug, right? Now plug all those pieces into our formula, chug away at the work, and you've got it right there, okay? So if you're new to these rules, or if you're just really organized, like I would probably do this myself if I were working these out, you can do something like that. If you kind of want to just mentally take these derivatives and fill them into the formula as you go, and if you're confident in your work, that'll work as well, all right? So got my original function here. P of x is equal to this. The derivative now, P prime of x is equal to, let's see what we've got. So again, I'm going to preserve the order that I've written things up here. So I've got g times f prime. So g, x minus x squared, the original second term. So I've got x minus x squared, wrapped in parentheses, times f prime, which is just 4x. Okay. Do I need that multiplication dot? No, I can just kind of smush it next to it for multiplication. Do I need parentheses around this 4x? Also, no, I don't, but let me put them there. So I've just got g and I've got f prime being multiplied together, all right? Plus, and the other two pieces. So the original f, 1 plus 2x squared, and my little mise en place bubble is getting in my way here. So I've got the original f times g prime. G prime, I do need parentheses, 1 minus 2x, because I've got more than one term in there. All right, so squeeze those guys together with parentheses. Okay, so for both of these are binomials, because I've got the plus and the minus there. You need the parentheses so we can FOIL, we can distribute these terms together. Here I don't need them, but doesn't hurt. Okay, now what I want to do is so what I've done there is use the product rule, right? I've set up the product rule, but that doesn't look like a clean, nice final answer. So now what I want to do is distribute everything together, combine some like terms, and then we'll be done. So here I've got 4x to distribute inside these parentheses. So 4x times x is 4x squared. 4x times x squared is 4x cubed, and I'm subtracting that. So minus 4x cubed, all right? Here I'm adding, so that's nice, and so I don't have to distribute a minus, and so I've got to FOIL this, right? So here I'm going to have 1 times 1 is 1, and I'm adding that, so plus 1. 1 times minus 2x is going to give me a minus 2x. 2x squared times the 1 is going to give me this plus 2x squared. And finally, 2x squared times this minus 2x is going to give me 4x cubed. So I'm going to get minus 4x cubed. All right. So that's looking kind of good. And let's see what we've got going on now. So for some reason, WebAssign, and most students did this too, listed the answers in increasing powers, which that's fine. So here I've got a constant. The only constant I see is a 1. So 1 is cool. Sometimes what I like to do, it's just my own habit when I'm collecting like terms or something like that, is sort of circle the terms that I've already dealt with, just so I don't get confused. So I've dealt with my constants. I only see one linear term here with the x to the first power. So I see a minus 2x, and let me circle that term so sort of check it off. What about squared terms, quadratic terms? I see 4x squared, I see plus 2x squared, so I see all together plus 6x squared. So I've added those guys in, or we're taking those into account. And finally, minus 4x cubed minus another 4x cubed is going to give me minus 8x cubed. All right. And there we go. So that's an example of using here, we use those cubes up. That's an example of using the product rule. Okay, so a valuable rule, there are times where you have to use it, where you don't have any other choice. This isn't one of them. We could have done this a different way. And so I'm going to do it the other way and actually show that it's easier. So when you can avoid this rule, seems weird as a teacher to teach a rule and then immediately tell students, try to avoid this. But if you can avoid this, might as well. It's a little bit less work, all right? Particularly, let's think about what we had to do. So I had my original function here, which was this little polynomial times this little polynomial. When I took the derivative, I ended up with this product. So I had to distribute the 4x across this minus. That wasn't so bad. And then here I had these two terms and I had to FOIL them together. Right? So not really so bad, but I had to FOIL a binomial with another one. Then here I had to distribute, and then I had a bunch of terms that we had to combine. Okay, so that works. Let me leave this as my final answer down here. But let's approach this a different way. So let me get rid of the product rule since I'm not going to use it. Get rid of the mise en place, the pieces we used for the product rule since I'm not going to use it. And let me get rid of all the work here that we did to get that derivative. So I'm just leaving my original function here. And then here's its derivative, okay? So let me kind of work upwards a little bit. Let me rewrite the original function, which some of you might be tempted to say, well, wait, yeah, I've got a product here, right? But why can't I just FOIL this term with this to begin with? And then I don't have a product. And then if I don't have a product, I don't have to use the product rule. Meaning, let's FOIL right off the bat. So 1 times x gives me x. 1 times minus x squared is going to give me minus x squared. Right? 2x squared times this x is going to give me 2x cubed. Right? And then 2x squared times this minus x squared will give me minus 2x to the 4. Okay. So, to avoid the product rule, I had to FOIL right off the bat, right? So you might think that's a little extra work, right? We didn't have to do that earlier, right? I didn't have to FOIL, but that wasn't so bad. And when we did the product rule, we ended up having to FOIL a lot anyway, right? There ended up being a lot of distributing to ultimately do. And we had to keep all our pieces, we had to find those derivatives, we had to keep everything straight, right? Plug it in where it belongs. So there were a lot of things to worry about. So when you can do something like this, let's go ahead and do something like that. And so I'm kind of working like this. This guy, P of x is still this. I haven't done anything. But let me take this now down here and write P prime of x. In other words, now I'm just going to take the derivative of P, but I'm going to use this form of P. Right? This is really the same thing. So now there's no product anymore. The only products I ever see are these constant multiples, right? And those we have the constant multiple rule. So I don't need to use the product rule at all here. I've got pluses and minuses, so I'm using the sum and difference rules from the previous sections, but those are easy. So I'm just going to go term by term and take the derivatives. So derivative of x is a 1. The derivative of x squared is 2x, right? I'm subtracting those, so put a minus here. Derivative of this, combining our rules, 3 times 2 is going to give me a 6. X, decrease that power to a 2. I was adding those, so I'll put the plus sign inside. And then now finally, same rule, 4 times this 2 gives me an 8. X, decrease the 4 into a 3. And then that minus sign comes through. Boom. Same exact thing, right? So you guys tell me what was easier, to FOIL right off the bat and then just take a straightaway derivative and we're done, or to make all those 4 pieces for the product rule, put them all together, do a bunch of distributing, collect all our like terms, have to cancel, keep track of what's going on. So yeah, so this is a nice example where the avoiding the product rule was really smooth, right? Really quick. Not always this quick, but when you can avoid it, I would avoid it, right? I wouldn't use the product rule if I don't have to. So there you go. Okay. But what if you do have to? So for instance, let's say, this is a good one to do in person. Let's say I've got this function, x e to the x, right? How am I going to take the derivative of that? Well, that's a product. X is one function here, polynomial power function, and then e to the x is an exponential function, okay? When you've got this e to the x, or later once we get into trig functions or kind of strange functions where they're not just polynomials, and there's nothing really to just FOIL, right? So I can't really do anything nice with this product, so I pretty much have to rely on the product rule, all right? So first things first, let me call it P of x again, and that means because I want to call the first piece, that first function x, I'll call f, and then the second function, e to the x, I'll call g, okay? So I'll set up my pieces over here. F prime of this function, the derivative of just the function x is just a 1, and what we saw from the previous section is the derivative of e to the x is itself e to the x. Okay, so I've got these 4 pieces, and now let me go ahead and plug everything into the derivative rule. All right, so derivative of this product p, the way I do it is g times f prime. So the second function, e to the x, times the derivative of the first function. Let me actually write it out step by step using the d notation here. So this says the second function times the derivative of the first function plus the first function times the derivative of the second function. Okay? Just practice writing out the product rule one more time. When you write it out like this, I haven't actually taken any derivatives yet. In other words, here I've indicated what the derivative of our first function is and what the derivative of our second function is, right? But since I've spread it out like this with our denotation, I actually haven't applied those derivatives yet. I'm just claiming that I'm going to take the derivative with respect of x to this function. And so now let me clean this up though. I've got e to the x times the derivative of x is 1, right? So that's the piece I had right there, plus the original x times the derivative of e to the x, which is another copy though of e to the x. All right. And that's what we get. And so one thing you might do here is say e to the x, let me factor that out. So I'm going to pull out an e to the x. And what I'm left with behind is a 1 plus x. All right. And there's a couple different things you might do here. So maybe I want to rearrange the order I write those things. So I can call that e to the x times x plus 1 or 1 plus x, however you want to handle that, right? But there. So that was a pretty easy example, but there's no avoiding the product rule in that case. Okay, so when you've got one or more sort of complicated functions, not just polynomials, probably got to rely on the product rule. If your product is just 2 polynomials, my recommendation is push them together, FOIL them, distribute them, whatever you're going to do, and then just take your regular rule derivative. All right, there we go. Next video will be an example of a quotient rule to round out this section. Okay.